Hi, today we're going to be looking at a topic titled thermal expansion. Now, we are quite familiar with the word thermal and with the word expansion. Expansion means an increase in the size of a substance, while thermal means heat. That's heat produced due to a change in temperature. Now, here we said that all substances increase in size with rising temperature because the most common effect produced by temperature or temperature change is a change in the size. So, any substance or any solid that is exposed to heat, that is exposed to a temperature change, that substance or that a solid is bound to change in its size. So expansion is the increase in size, maybe in the length of the substance. That means the substance can increase in length, it can increase in the breadth, it can increase in the height, or in its volume, or even in its area. So thermal expansion is the increase in size of a material or of a solid due to increase in temperature. So whenever there is an increase in temperature, solids are bound to increase in size, they are bound to expand. And also, whenever there is a decrease in temperature, solids also are bound to contract. Thus, increase in temperature means an expansion, while a decrease in temperature means a contraction. All right. This is we have here linear expansivity. The change in one dimension of a solid, maybe the change in the length, or the change in the width, or the change in the breadth of a solid is called linear expansion. Either a change in the length, or a change in the height, or a change in the breadth of a solid due to thermal change is called a linear expansion. Now, it is defined as the net increase in length. That is the total increase in length of that solid per unit length, and also per degree rise in temperature. Mathematically, alpha, which stands for the coefficient of linear expansion, is given by the change in length, that's delta L, all over the unit length, that's the original length, and then per degree rise in temperature, that's the change in temperature. I can use T, but some books will use theta as the temperature sign. So here, um, the alpha stands for the coefficient of linear expansion. The change in L stands for the change in length. That's the delta L. While the L0 is the original length of that solid before it was increased in length due to temperature change. It's the original length of the solid, and then delta T is equals to the change in temperature. Change in temperature. Okay. All right. This is a question for us to solve. whereby we are going to apply the formula that I gave to you and then get our answer. The question is, a wire 20 meters long is heated from a temperature of 5 degrees Celsius to 55 degrees Celsius. If the change in length is 0.02 meters, calculate the linear expansivity of the wire. Okay, now let's have this. First of all, let's write out the data that was given to us. The first one is what? A wire 20 meters long. That is the original length of the wire. That's L0 is what? 20 meters. That's the original length of the wire is 20 meters, and that's our L0. Okay, it's heated from a temperature of 5 degrees Celsius to 55 degrees Celsius. That means this 5 here stands for what? The original temperature of that wire. And 55 stands for the final temperature of the wire. So at T0, that's the original T0, is equals to what? 5 degrees Celsius. While final temperature, let me call it T1, is equals to 55 degrees Celsius. And from these two data that we have here, we can find our change in temperature. That's the difference in temperature. That's T1 minus T0. That's by how much did the temperature of the wire rise. And that will give us 55 minus 5, which will give us what? 50 degrees Celsius. That's our change in T is 50 degree Celsius. Okay, I've gotten L0 delta T. Whereas was given to us, if the change in length is what? 0.02, that means after the wire was heated from 5 degrees to 55, it increased in length by a value of 0.02. That means our change in length, that's the amount by which the wire increased, is what? 0.02 meters. Okay, now we're asked to calculate the linear expansivity of the wire, which is what? Alpha. That's what we're asked to calculate. And then I gave you a formula that alpha is equals to a change in length all over L0 multiplied by change in temperature. And that will give us what? Was my change in length? 0.02. What is my original length? 20 meters. Here's my alpha. Times what's my change in length? 50. Permit me to solve here. And that will be alpha is equals to what? 0.02 all divided by 20 times 50 will give us what? 1000. 1000. Now divide 0.02 by 1000. If I move backwards 3 good times, that will give us I think 0.00 as 1 2 3 1 2 0.00002. I think that should be the answer. 0.0002. Let's check. 1 2 3. Yeah, that's 0.002. And the unit for linear expansivity is per degree Celsius. Yeah. And now let's change this to standard form. That will give us 2 times 1, 2, 3, 4, 5. 2 times 10 to the power of negative 5 per degree Celsius. That's the value of the linear expansivity of the wire. Okay, this is another question. A metal rod 100 cm is heated through 100 degrees Celsius. Calculate the change in length of the rod if the linear expansivity of the rod is 3 times 10 to the power of negative 4. So let's write out the parameters that was given to us. What is the original length of the metal rod? That's our L0 is equals to what? 100 cm. True. Now look at that word. Is heated through 100 degrees Celsius. That means the original temperature is what? 0. Why the final temperature is what? 100. Because they did not give us any original, but they gave us the final. That means the original temperature is what? 0 degrees. Why the final is what? 100. Or you can say that the change in the temperature is just what? 100 degrees Celsius. So we can take it that the change in the temperature is just what? 100 degrees Celsius. And we're asked to calculate the change in length of the rod. That's at delta L. We're asked to calculate it. We don't know it. And then our alpha is given by what? 3 times 10 to the power of negative 4 per degree Celsius. Now let's slot it into the formula that was given to us. Alpha is equals to change in L all over L0 change in temperature. What is the value of our alpha? That's 3 times 10 to the power of negative 4. What was our change in L? We don't know it, and that's what we are solving for. What was our original length? 100 cm. What was our change in temperature? 100 degrees Celsius. Now I can call this one to be all over 1. And you cross multiply, you have that change in L times 1 is still what? Change in L. And that will give us 100 times 100 times this. That's a 3 times 10 to the power of negative 4. Now let me change that 100 to times 100 to a standard form. That will give me 10 to the power of 4 because here you have four zeros, 1, 2, 3, 4. So 10 to the power of 4 or 1 times 10 to the power of 4, which is still something as 10 to the power of 4. Times 3 times what? 10 to the power of negative 4. Okay. And this automatically will give me that 3 times 10 to the power of negative 4, positive 4 times 10 to the power of negative 4. And if you apply the law of indices here, these two will cancel out. That's 10 to the power of 4 minus 4 will give us 0. And 10 to the power of 0 is 1. So 1 times 3 here will give us 3 times 1, which is a change in length is equals to what? 3. 3 cm. That means the metal rod was increased by 3 cm when it was heated to 100 degrees Celsius. So these are answer for the change in length. Okay, here is your assignment for the day. Number 1, a metal rod 100 cm is heated from 20 degrees Celsius to 70 degrees Celsius. Calculate the linear expansivity of the rod if its change in length is 5 cm. And then the second one, a metal rod of length 40 cm at 20 degree Celsius is heated to a temperature of 45 degree Celsius. And if the new length of the rod is 40.05 cm, calculate the linear expansivity. Now, this 40.05, we serve as the what? The new length, that's L1. Why this 40 cm is the L0. So after you will get the change in length, which is the L1 minus the L0 to get your change in length. And after that, you slot it into the formula and get your answer.